Hello students, it's Mrs. Wilborn again, back with lesson 2, and in this lesson we're going to cover experimental probability, and this is the second type of probability. So if you have your guided notes in front of you, you can go up and you can find where it says lesson 2 and start filling in the definition here. So experimental probability is the probability that is based on repeated trials of an experiment. Examples such as rolling a dice, flipping a coin, pulling cards from a deck, anything like that. Anything that you're going to repeatedly do and as an experiment. Each trial in which the event that you're looking for occurs is considered a success. So if you're trying to figure out the probability of flipping a coin and it landing on heads, and you were going to do this several times as an experiment, every time the coin did land on heads, it would be considered a success. Just as with theoretical or uniform probability, we have a formula, and the formula for this is the number of successes, so each time you get the outcome you're looking for, over the total number of trials, so how many times you actually tried the experiment. Right, and just like the last time, we have a couple examples, and then you'll try a couple problems on your own. All right, so here's our first example, finding an experimental probability, example 1. A cat that knows the shake command offers either of its paws to shake. The table shows the number of times the cat offers each of its paws when asked to shake. What is the likelihood that the cat will offer its right paw when asked to shake? All right, well, we kind of gathered our data from our experiment in this little table. And since we're looking specifically at the right paw, and out of the total trials, the cat gave the right paw 12 times, that would be our successes. So we have that in our numerator. And the total number of trials would be, in this case, 50, and I got that from adding 38 and 12. So if I added these up, I would get 50. So 12 over 50, successes over trials, was my formula, how I substituted in my formula. Then of course I would reduce that, and so I would get 6 over 25, which is simplified. And so my solution would be 6/25, or if I change that to a decimal, 0.24, or to a percent, 24%. So there's a 24% probability based on the experiment and the data we gathered that the cat would offer its right paw. All right, here is another example. And for this one, I will go ahead and get my Enwrite pen going. So bear with me just a second. Oops. Alright, so in this question, a game spinner was spun 500 times. The results of the spinner are shown in the table below. What is the probability that the spinner will land on A? Alright, well, if we use our formula that we know, so our probability of the spinner landing on A equals the number of successes over the trials. So in this case, it landed on A 128 times. And the total number of trials, which I know from my directions or my word problem up here, was 500. Alright, I could also have added these numbers and would have gotten that as well. So I have 128 over 500. So I need to go through and reduce that. And I know 2 is a common factor, so if I divide that out, I'll get 64 over 250. Alright, well, both of my numbers end in an even number, so I know that's still divisible by 2 again. So that gives me 32 over 125. Alright, and if I were to write that as a decimal, I would just divide the bottom into the top. So I would go ahead and I'll kind of do it over here, put 32 in the house and 125 on the outside, add a decimal point and a 0, and then I would go through and divide out, and what you would find is that it was 0.256. And then to change that to a percent, I just simply move my decimal 2 spaces to the right. So I have 25.6%. So my 3 solutions here could be 32 over 125, 0.256, or 25.6%. So any of those, depending on how the question was asked. In this case, it didn't tell me any specific way, so I'll just list all 3. Alright, so I hope that helps you with experimental probability. Let's give you an opportunity to try one on your own. Alright, so finding experimental probability on your own. Alright, you got 2 problems, the first one and the second one down here. And so again, what you'll do, go ahead and hit your stop or pause key and solve these on your own. Make sure you're showing all your work and of course reducing, and then we'll go over these in class tomorrow. Okay? Good luck. Alright, and now the next part of this is going to be sample spaces and experimental probability. If you remember, a sample space is a list of all the possible outcomes and finding the probability of each possible outcome and being sure that they add up to 1. Remember, the sum of all of the possible outcomes does equal 1. So you may want to go back in your notes and review what a sample space is. For this one, actually, I'm going to have you do this one on your own. So consider example 1 with the cat and see if you can figure out the sample space for this. And we'll go through and, again, go through this in class tomorrow. Alright, and one more for you to try. So this also you'll do on your own. Again, hit the pause key, try the sample space, answer the question, and then we'll go through these in class tomorrow. So add this to your homework, and good luck. Again, come with questions, jot down questions that you may have, and we will go through this tomorrow. All right, take care.